This is Lesson 19, Polynomial Division. As I indicated in the end of the last lesson, earlier on we had done adding, subtracting, and multiplying polynomials, and you may have said at that point in time, what's wrong with dividing? Well, we had to do a few other things, and now we're finally ready to divide polynomials. And the dividing of polynomials is very important because it's going to lead us into a way to solve all kinds of polynomial equations. And we'll do that, in fact, in the lesson number 20, which of course comes after this one, this being lesson 19. Now, what we're going to do first is go through a long division problem in polynomials and sort of relate it back to 4th grade when you learned how to do long division with numbers. Remember I said that a polynomial is really nothing more than a whole number, but the place values are powers of x rather than powers of 10. Then I'm going to go back and show you a quicker and quite easier way to divide polynomials. Getting through that may take a while, and again, that's the advantage of having this on tape, because what I will do is side by side go back again through the division process and this new method called synthetic division. Then we'll do some problems using synthetic division to divide polynomials. And if we have a chance, we'll begin to get a flavor of what we're going to do in lesson 20, which is about solving polynomials that are set equal to 0, or the zeros of polynomials. But let's go ahead and do our long division problem. I've already written it on the board. And we have x plus 3 divided into x cubed minus 2x squared minus 16x minus 2. Now, remember in long division, what did you do? You said, okay, how many goes in here? But it's not quite the same exactly. What we're going to do is simply, in our dividing, look at the x over here and divide the x into the x cubed. And what times x is x cubed? It's x squared. So we're going to put x squared, line it up just like we did in 4th grade or 5th grade or 3rd grade if you're an advanced student, long division. Notice, by the way, if this had been 8x cubed, this would have been 8x squared, because this is 1x. Had this been 3.7x cubed, this would have been 3.7x squared, because again, we're dividing by 1x. Now, think back to your elementary school days. After you divided, what did you do? You multiplied. And you multiplied what you had here by what you were dividing by. And now we're going to do that. We're going to multiply the x squared by the x plus 3. Well, x squared times x is x cubed. And x squared times plus 3 is a positive 3x squared. What did you do next? You subtracted. Now we're subtracting polynomials. Remember, in subtracting polynomials, we can either subtract each term, and they are lined up for that purpose, or we can change all the signs in the second polynomial and use our addition rules. I'll do it that way. I'll change this to a minus, since subtracting a positive x cubed is the same as adding a negative x cubed. And I'll change this plus to a minus 2. I like to circle the plus, indicating that I've changed it. And now we can add. Well, of course, this and this will always cancel out, because no matter what, this times this will be the same, that'll be it. So there's no problem there. That's going to zero out. We have a negative 2x squared and a negative 3x squared, which I believe is negative 5x squared. We change the sign, and we are adding. Just in case I make an error, I think we need to have this piece of paper, because sometimes, you can make mistakes, and we don't want you going through a tape with mistakes. Now, what did you do next in your elementary classroom when you were learning to divide? After you subtracted, you brought down the next place value. And the next place value here is negative 16x. Everything is lined up. And after you brought down, you divided. So, we'll divide x into negative 5x squared. Well, 1 times what is negative 5? Negative 5. And x times what is x squared? X times x is x squared. And again, we line up the x with the x in the original problem that we're dividing into. Okay? Now notice, had this been negative 17x squared, this would have been negative 17x because this is 1x. No matter what this coefficient here is, it's the same there. The only difference is we've lowered the degree of our monomial. This was x squared, it's x. Over here we started with x cubed, and of course that's x squared. Now, we're going to multiply negative 5x times x plus 3. Negative 5x times x is negative 5x squared. Negative 5x times 3 is negative 15x. Subtract. And again, to subtract, we are going to change the signs in the second polynomial and add. Use our adding rules. So I change these two minuses to pluses. And what do I see? Well, obviously, this cancels out. It has to. Because when we multiply, we knew that this times this would give us this. So when we subtract, we should get 0 there. A negative 16x, a positive 15x gives us a negative x. And of course, we do next is to bring down our next place value, which is the ones place, or the constant, negative 2. We divide x into negative x. And what happens there? Well, what times x is negative x? Negative 1. And you'll notice the negative 1, of course, is lined up with the negative 2 in the ones or constant place. Okay, then we multiply. Negative 1 times x plus 3 gives us negative x. And a negative 1 times a positive 3 is negative 3. Okay, looks right. We're going to subtract now. Change the signs and use the adding rules. That cancels out, and we're left with a 1. Since there's nothing left to bring down, that's our remainder. Now, back in 4th grade, you wrote R1 or something like that. But now we know we can write the remainder as a fraction. The remainder over the number we divided by. So we can put plus 1 over x plus 3. So that's our answer. And again, not a very difficult process, but as you can see, sort of long-winded, and it'll be nice if you could do this more quickly using less paper or less chalkboard. And that's what we're aiming to do here. We're aiming to find out about this synthetic division that allows us to do this much more quickly. Okay, let's take a look at the next, or the first visual actually. The first visual is, again, the same thing we just saw. Okay, it's the x plus 3 divided in, and we have the remainder down there. So in case those of you don't like white chalk on green boards, but rather have white on blue visuals, you can see that. In this particular case, what I've done, rather than changing the signs, for those of you who like to simply subtract, I've put the things we subtracted in parentheses with a negative outside. So again, if you don't like the way I did it at the board, go back to this visual, pause, copy it down, and run through it so you can see how it was done. The next visual, in effect, shows you what we've done. So let's take a look at that next visual. We have a division problem, and the answer is x squared minus 5x minus 1 plus a remainder of 1, which means 1 over x plus 3. At the bottom part of the visual, what I have done is replace the x with 10. Just as we checked polynomial addition, subtraction, multiplication, we can check polynomial division by replacing the x with 10. And therefore x cubed is 1,000, minus 200, minus 16 times 10 is minus 160, minus 2 divided by 13. And that's 638 divided by 13, which turns out to be 49 and 1/13. So that's the answer if x is 10. Well, let's look at our answer. Our answer was x squared minus 5x minus 1, which is 100, minus 50, minus 5 tenths, minus 1, which is 49, with the remainder of 1. And 1 over 10 plus 3 is 1/13. So indeed, it checks in both ways, plugging the 10 in to the actual problem and working out the arithmetic, or plugging the 10 into the answer, we get 49 and 1/13. But as I said, this is not the most efficient way to do polynomial division. So what we're going to do is we're going to introduce a new method. And as I've done on a few occasions in previous lessons, I am going to go through the whole thing explaining why it works. If you don't understand it totally, if you don't want to understand it, that's fine with me. But I believe my students should see why methods work. Ultimately, you'll see the method, and the method is a simple method to use, the method of synthetic division. So, what we're going to do is, over here on this part of the board, I'm going to do the synthetic problem just like that problem there. The exact same problem done synthetically. And as I do it, I will go from here to the synthetic problem, showing how they're the same and why the synthetic problem works. Now, you'll notice the first thing we saw is that we had x cubed, x squared, x, and our constant term, and we knew that since this was x, and of course synthetic division, by the way, only works when you're dividing by 1x plus or minus some number. It has to be 1x, and we'll run into a problem later on that will not have a 1x, and we'll see what we do. When I divide x into x cubed, I get x squared. When I divide x into x to the fifth, I get x to the fourth. When I divide x into 2x squared, I get 2x. When I divide x into negative 17x, I get negative 17. In other words, what I get in the answer is always the same coefficient. So when I divide it here into x cubed, I got x squared, the coefficient of 1. When I divide it into negative 5x squared, I got negative 5x, the coefficient of negative 5. When I divide it into negative x, I got negative 1, a coefficient of negative 1. And the degree of the monomial I'm dealing with was 1 less. X cubed became x squared became x, etc., because I'm dividing by x. So we don't need to worry about writing down the x cubes and x squareds. We're just going to write down the coefficient. So let's take the coefficient of the coefficients, I should say, of the number we're dividing into. That is, 1 is the x cubed coefficient, minus 2, minus 16, and minus 2. So we've written down the original problem's coefficients. Okay? Now, let's go back over here and look at x plus 3. We don't need to worry about the x because we know that when we have x squared times x, it's going to give us x cubed. We're going to subtract. It's gone. All we're really concerned about is the plus 3 because that gives us the thing we're going to work with next. We multiply the x squared by 3x, by 3, I'm sorry, x squared by plus 3, got our 3x squared, and subtracted. We subtracted here by changing the sign and adding, but this was the key. When we did our next division, it was based on what we had gotten out of this plus 3. Now, remember, we multiplied this by the plus 3, and then what did we do? We subtracted. We changed the sign and added. Why not simply, since all we're writing down is a plus 3, change the sign first and then just add when we get to that point? Okay, let's try that. In other words, what I'm going to do is over here I'm going to put the opposite sign of x plus 3. The opposite of plus 3 is minus 3. Now, when I divide it, again, x into x cubed gave me x squared. I know, since we're dividing by x, if this is x cubed, this is going to be x squared. If this is x to the fifth, this is going to be x to the fourth. And I also know, since this is 1x, that the coefficient will be the same. We said if this had been 2x cubed, this would have been 2x squared. So all I need to do is this coefficient is the same as this. So all I got to do is bring down this coefficient. And my answer, or the coefficients of my answer, will be right here. What did I do next? What I did next over here is I took that coefficient and multiplied it by the 3. I'm not worried about the x squared because I know it's going to be in the x squared place. 3x. And then I changed the sign to add instead of subtracting. Well, hey, I've already changed the sign, so all I need to do is multiply this coefficient by this. That is, multiply this coefficient by negative 3, and that's going to go in the x squared place. And of course, since this was the x cubed place, this is the x squared place. And there's my negative 3. And since I've already changed the sign, I don't subtract, I simply add. Negative 2 plus negative 3 is negative 5. And notice, that's exactly what I got in my answer. Negative 5x. And what did I do with that negative 5x? I multiplied it by the 3 and changed the sign That is, I had negative 15x, and I wound up with a positive 15. Let's do the same thing over here. We multiply negative 5 times negative 3 and get positive 15. That's same 15. And, of course, this is in the x place. And after we change the sign, which we've already done, we add it. A negative 16, a positive 15 gives us negative 1. Notice that's what we had over here in the x place, negative 1. And what did we do? When we divided by 1x, we got negative 1. That is, there's the negative 1 in our answer in the x place. And then what did we do? We took that negative 1 and multiplied it by x plus 3. We don't really care about the x. We know that's going to be taken care of. Negative 1 times 3, and then we changed the sign, and we got a plus 3. Well, of course, negative 1 times negative 3, the sign being changed, we got a plus 3. And then we added, and we got a 1. And let's put that in a little boxel L-shaped thing, because that's our remainder. Well, since I know the problem started out with x cubed, the answer has to be x squared as the highest power, because I'm dividing by x. Or I can say 1, 2, 3. This is the ones place, the x's place, the x squared place. My answer is x squared minus 5x minus 1 with a remainder of 1, or 1 over plus 1 over x plus 3. And that's exactly the same answer I got before. And again, we've gone through it slowly, so it seems like this method is certainly not more efficient. But in reality, all you do is when you're dividing by x plus 3 is change the sign, make it negative 3. Write down the coefficients of the number you're dividing into. Bring down the first coefficient, because that's going to be the lead coefficient of the answer. Multiply, add, multiply, add, multiply, add, and the last term is your remainder. And then count the places. We saw this was x squared. If we had 4 terms here, we'd start with x cubed. Write your polynomial with your remainder over x plus 3. Remember, had this been a negative 1, this would have been minus 1 over x plus 3. Okay? And we could check it the same way as we did before. Again, if you still are not sure about this, I would suggest you rewind the tape and go through the explanation I just did. Because what we're going to do now is we are going to look at a couple of problems using synthetic division. So let's take a look at the next visual. And the next visual has a division problem, 2x cubed minus 5x squared plus 3 divided by x minus 1. You'll notice we can use the division symbol, which is a horizontal line segment with a dot above and a dot below, or a slash. And for those of you that are computer buffs or use a graphing calculator, you know that division will come up as a slash, as it is here. Okay, so we're dividing by x minus 1. Below that division problem, we have the problem worked out using synthetic division. Let's go through the problem. The first thing we should notice is, although the highest power is x cubed, there's only 3 terms. There should be 4 terms. What went wrong? Nothing is wrong. There is no x number. Well, when we write down our coefficients, we have to include a coefficient for each place value. And therefore, you'll notice in our synthetic division problem, we have 2 for the x cubed, negative 5 for the x squared, 0, which is highlighted in blue to show you that this is special. We're putting a 0 in for the x, and of course a 3 for the constant term, positive 3. And over to the left, we have our number representing what we're dividing by. Since we're dividing by x minus 1, we change the sign in anticipation of having to change the sign and add to subtract. We change the sign to 1. Okay, and then we simply bring down the lead coefficient, which is 2, because when we divide 2x cubed by x, we're going to get 2x squared. We multiply the 2 times the 1, and we get 2 in the next place, in the x squared place, excuse me. We add negative 5 and 2 is negative 3. That is the coefficient of our next term. We multiply that by 1, which is negative 3. Add it to 0, again, keeping in the place values. 0 plus negative 3 is negative 3, which gives us our last value of the negative 3 in the ones place. We multiply, which is negative 3 times 1 is negative 3. And we have a remainder, which is in red, of 0. Why is that remainder in red? Let's talk about that after we once again discuss what our answer is. Our answer is that if 2x cubed minus 5x squared plus 3 is divided by x minus 1, we get 2x squared minus 3x minus 3. That's our answer. And of course, there's no remainder. Now let's talk about what the remainder of 0 means. A remainder of 0 means that when you divide x minus 1 into this polynomial, you get no remainder. What do we call a number that divides another number without a remainder? It is called a factor or a divisor. In other words, x minus 1 is a factor of 2x cubed minus 5x squared plus 3. In fact, x minus 1 times the answer. X minus 1 times 2x squared minus 3x minus 3 equals 2x cubed minus 5x squared plus 3. And later on, we talk about solving polynomials, knowing that a binomial is a factor, using synthetic division and getting a remainder of 0, we will say then we have a definite solution. In fact, not a possible solution, but a definite solution to solving a polynomial equal to 0. So the notion of finding a factor using synthetic division is very important. Okay. Let's take a look at the next visual. The next visual shows us that we need to check. Here's the same problem with the answer. Again, all the work was done using synthetic division, but now we've replaced the x with 10. And 2x cubed minus 5x squared plus 3 becomes 1,503. We divide that by 10 minus 1 by 9, and we get 167. And I bet you know what 2x squared minus 3x minus 3 is when x equals 10. Yes, it is 167. It checks. Okay, let's look at the next visual. The next visual, as promised earlier, shows us a situation where we're dividing by something other than a binomial whose coefficient of x is 1. We have 3x squared minus 9x plus 6 divided by 3x minus 1. Picture this problem as a fraction, a division problem written as a fraction. The numerator would be 3x squared minus 9x plus 6. The denominator would be 3x minus 1. If we wanted to change the denominator, we'd have to do the same thing to the numerator. So if you look back at the visual, on the second line, which is highlighted, you see that we've divided both the first number, that is the number that would be the numerator or the number we're dividing into, and the divisor, which would be the denominator, by 3. And of course we get x squared minus 3x plus 2. It was fortuitous that the polynomial we're dividing into is easily divisible by 3. Of course I chose it that way. And the 3x minus 1 divided by 3 gives us x minus 1/3. The 1/3 is unfortunate of a fraction, but things will work out somewhat decently. All right. Below that line, we have the actual synthetic division. Since we're dividing by x minus 1/3 in that little box, or we're going to call it in the upper left-hand corner of the synthetic division, we put positive 1/3. We write down the coefficients 1, negative 3, and 2. We bring down the first coefficient, 1. Multiply 1 times a third. Add negative 3 plus 1/3, we get negative 8/3. That is negative 9/3 plus 1/3 is negative 8/3. We multiply the negative 8/3 times 1/3 and get negative 8/9. We add the 2, which of course would be 18/9, and the negative 8/9 and get 10/9. That's our remainder. And thus the answer, x for 1x minus 8/3 plus the remainder 10/9 over x minus 1/3. Pretty messy looking answer. But that's okay. I made this problem a little messy, so that if you couldn't do it the first time through, you can go back, try it on your own, view the tape again, and if you can do this, you can do any other problem that comes out less messy. But notice what happens in the next visual. Because in the next visual, what we've done is rewritten the answer, x minus 8/3 plus 10/9 over x minus 1/3, and taken that fraction, taken that remainder, and multiplied it top and bottom by 3. Why by 3? Actually, I'm sorry, we've multiplied top and bottom by 9. And the reason we multiplied it by 9 is the largest denominator there is 9. The least common denominator for the ninths and the thirds in our fraction would be 9. We multiply top and bottom, and we get x minus 8/3, which is unaffected, and the fraction plus 10 over 9x minus 3. And of course, that's a lot easier to read. It's still a bit messy, but the fact is it is correct. If you wanted to check it, you could again replace x throughout the problem with 10, and it would check. Let's take a look at another problem. This time let's do this at the board. Okay? Erase all this stuff over here. And we'll take a look at another division problem with some interesting results. Let's take x cubed plus 5x squared minus 4x minus 20 and divide that by, let's see. How about divide it by x plus 5? And I want to do this synthetically. Well, the first thing I want to do is write down my coefficients. I might check to make sure they're all there. Third power, second power, first power, constant, they're all there. 1, 5, negative 4, negative 20. And since I'm dividing by x plus 5, I change the sign and synthetically divide by negative 5. Bring down the first coefficient, multiply. I multiply and then I add that 5 and a negative 5 is 0. There's my next coefficient. I multiply. Let's see, 0 times negative 5 is 0. I add negative 4. I multiply, and I get positive 20. And very nicely, I have a remainder of 0. What's even nicer is that this polynomial, of course, this is the x squared plus 0x minus 4. And I know what that's equal to. That's equal to, back our old factoring games, x plus 2 and x minus 2. And what I have found out is that not only is x plus 5 a factor of this, but that x plus 2 and x minus 2 are all factors. In fact, if I multiply x plus 5 times x plus 2 times x minus 2, I would get the x cubed plus 5x squared minus 4x minus 20. That will be very important in the next lesson. Let me do one more problem fairly quickly here to demonstrate something we did earlier in our factoring investigation. Let me divide x cubed minus 64 by x minus 4. And again, writing down the coefficients. 1, I notice there's no x squared term. There's no x term. I keep putting zeros down until I get over here, and there's my negative 64. Okay? I'm dividing by x minus 4, so what am I going to do? I am going to put a negative 4, no, a positive 4, because I always change the sign in anticipation of changing the sign and adding. Bring down the first one. 1 times 4 is 4. 0 plus 4 is 4. 4 times 4 is 16. 0 plus 16 is 16. 16 times 4 is 64. And of course, I get a remainder of 0. So not only have I found out that x minus 4 is a factor, but of course I have the other factor. And that would be x squared, 1 less power than the x cubed, plus 4x plus 16. We've just used synthetic division to verify the pattern we called the difference between two cubes. And if we can do the same thing to verify the pattern for the sum of two cubes. So we've seen some synthetic division problems. We'll be using synthetic division. So if you still aren't sure, go back and try them. Check them. Because in the next lesson, lesson 20, we're going to use synthetic division to help us solve polynomial equations where the polynomial is set equal to 0. That is, lesson 20 will involve the zeros of a polynomial.